Hey, welcome back to another week. And today we're going to start off kind of with an algebra proof to refresh our memory. And then we're going to kind of segue into some geometry proofs. And we're going to hopefully see that in a lot of ways, the geometry proof is not that much different from the algebra proof. So if we take a look here, this first proof we're looking at, the structure is already kind of filled in. Our statements are already taken care of. We just have to come up with our reasons. As we know, the first reason is always given. We write that problem. So we look here and we see how did they get to that second line. And hopefully you guys can see that they brought this 2 in to both of those. 2 times x is 2x. 2 times negative 12 is negative 24. And so that is what we call distribution, distributive, distribute, any of those. Okay. So distribution is what I'll put. Now, to get to the next line, in order to get a 64 over here, they add 24 to both sides. So that one is addition. And our final one here, they divided both sides, so division is our property. So this one was kind of set up with part of it filled in so that we could kind of get an idea of what to do. Once again, that's review. We did that last week. If you still aren't understanding that, please send me an email, reach out, let me know. I can work with you on those. So now this next one. And on this one, it's similar, except we have a little bit more information. We have a picture here. And now we're going to do some geometry concepts. Okay. So first here, the given information, AB equals 50. I'm going to go ahead and draw that into my picture. And I know you guys could solve this if you had to, but we need to set it up. If we look here, the given was already taken care of. They wrote that. Then AC, so that's this part, plus CB, that's this part, equals AB, the whole thing. That is known as our segment addition postulate. Okay, so I can just write segment addition postulate here. Oops, I accidentally put an O or an A. My O looks like an A is what I'm trying to say. So segment addition postulate, which tells us to remember the part plus the part equals that whole thing. Okay, now to get from this line right here to the next line, we are going to plug in each of these parts. So if we plug in and replace, that is known as substitution. All right, so now to the next line, we bring this 4 in. So that is distribution. And as you can see, this is now turned into just an algebra proof. The only difference is we had to use this geometry concept to set up our equation. We had to remember what segment addition was. That if we add the parts together, we get the whole thing. Okay, now they're on the same side. They do 2 of them in the same step, but that's because we're combining like terms for both of these. Then go ahead and if we subtract that 2, we're left with just 50 or 48 on both sides, so subtraction. And then our final step, we will divide. So as you can see, this proof really was just an algebra proof kind of in disguise. We had to use one geometry concept to set it up. Okay, so go ahead now, and the next one we're going to do is this 2-column proof on angles. Okay, so it's the same concept that we've done with angle bisectors. We know what that means, right here. We're just putting this into a proof now. So AB is the bisector of CAD, and that's our given. So if that is the case here, CAB, this angle, and then BAD, this angle, if it's the bisector, we know that those 2 angles have to be congruent. They're the same. Okay, and that is our definition. So I'm going to put DEF with a period. That stands for definition of bisector. A bisector always cuts it into two equal parts or two congruent parts. Now, from line 2 to 3, if these two are congruent, that means their measures are going to be equal. Right here, that should be an equal sign because these congruent angles have equal measures. Now, to get from line 3 to 4, we're going to go ahead and substitute in substitution. So right here, 7x plus 2 gets subbed in. The 5 parenthesis x plus 4 gets plugged in. So now, both of those take the place of what we had plugged in for this and this. So that's substitution. On the line 5, we're going to do something called distribution. We're getting rid of our parentheses. Now at this point, we got to pick it up and finish it out. So there's a couple ways you could do it. I'm going to go ahead and subtract the 5x here. And it looks like I'm short a line. We need one more line. So 2x plus 2 equals 20. That's subtraction. This next one, we'll subtract the 2 also. We'll get 2x equals 18. So that's subtraction again. And then I didn't make enough spots. Whoops. So step 8 should have x equals 9. And our reason is division. And notice right up here, it told us that that was our end goal. That was what we were trying to prove. If it tells you what you're trying to prove, that will always go on the last spot under statements. You never, 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 ever are going to have prove be written right there. I know we put given, but we are never going to put prove. If you put prove there, it will not be right. Okay? You're always giving a reason what is happening. So, next, let's look at a few of these properties. So if you want, pull out your property sheet on those algebra proofs to refresh your memory. But addition property of equality, if we add 6 to one side, we've got to add 6 to the other. It's supposed to be a 6. Okay, symmetric. Remember, this is when it flips the other way. So if LM is congruent to GH, then GH is congruent to LM. Distributive property, you guys are good at this one. We distribute that in. We'll get 30x minus 50. Multiplication property, if 2 over 5x equals 10, then 2x, here I can multiply by 5, that will cancel. If I do it to one side, I got to do it to the other. 5 times 10, hopefully you know, is 50. So substitution property, if jk equals 20, and AB plus JK equals XY, then we know that AB plus 20 equals XY. We replace it. It takes the place of that JK. And finally, the transitive property. Remember, we said we cut out the middleman. So if R is congruent to Z and Z is congruent to F, Z was used twice there, we can say that angle R is congruent to angle F. All right, so I'm wrapping up today's lesson. One other type of proof I want to look at briefly. These ones, are what we call a two-step proof. And two-step proofs are very simple, and they are just going to be some sort of definition. So I'm not going to do them all, but like this first one. It tells us what's given, so I'll go ahead and write AB, ray AB bisects angle CAR, and then we have to make some sort of conclusion. So that's given. We have to make some sort of conclusion. So if that's a bisector, then we know that these two angles are the same. And so I can just call that angle 5 is congruent to angle 6, and my reason, definition of bisector. Now, if you wanted, instead of calling that angle 5, you could have called it CAB or BAC. Instead of angle 6, you could have called it RAB or BAR. Okay. So another one here. Given angle 1 is comp to angle 2. So once again, that is given to us. And hopefully you know comp is short for complementary. So that means that angle 1 plus angle 2 will be equal to, hopefully you said, 90 degrees. And that is our definition of complementary. All right. I'm not going to do all of them, but this next one, B is the midpoint of NA. And if that's our given, if that's the midpoint, hopefully you know then that these two sides are equal. So we can say NB is, segment NB is congruent to BA. And our reason, definition of midpoint. This next one, I'm not going to write it out, but it'd be the same concept, sup. So the sups is short for supplementary. So we'd know that those two angles would add up to 180. Okay. Now likewise, on the back, some of these are kind of the opposite of what we already did. So, for example, on this one, if the measure of angle 1 plus the measure of angle 2 equals 90 degrees, that's given. If that is the case, then we know that angle 1 is complementary to angle 2, and our reason still is definition of complementary. Number 9, if AP is equal to PO, then that's our given. Hopefully you know if those two are equal, that means P is the midpoint. And once again, our reason is just definition of midpoint. So these two-step proofs are very short, but they give us just a little bit of information, something we can conclude using our definitions. So please try today's It's Learning assignment. Let me know if you have any questions. Hope you guys have a great day. We'll be back at proofs tomorrow, and then Wednesday and Thursday we'll continue practicing in class, and our Chapter 2 test is Friday. Talk to you later.